Good morning, madam. Madam,
Good morning, sir.
thank you for accepting my thank you for kind acceptance, madam.
So you are able to hear my voice, sir?
Yes, madam. Yes, madam.
Okay. So
Please start.
Ma'am, shall we start?
yeah.
Ladies and gentlemen, distinguished guests, delegates, participants, a very good morning to all. I'm Mr. Prakash Rao, working as Assistant Professor in the Department of Science and Engineering, the lineage of Engineering Technology, stand before you today with great honor and privilege as we gather here for the second session one in the third international conference on machine learning and big data analytics, ICMLBDA 2023. It's joint organized by National Institute of Technology and Northeast Asian Institute of Science and Technology, Arunachal, Pradesh, India. So on behalf of the organizing committee, it is my utmost pleasure to extend a warm welcome to each and every one of you. So we have an eminent and expert person, Dr.G.Jaya Suma madam, is going to deliver a talk on machine learning with IoT. So I deem it a pleasure and privilege to introduce profile of Dr.G.Jaya Suma madam. So Dr.G.Jaya Suma madam presently working as a professor in the Department of Information Technology and the Director in charge of Industry Institute of Interaction and Placements and Training Director of in charge of Faculty Development Cell and Executive Council member of JNTU Vizianagaram AP. She completed her BTech in CSN SC and MTech in CSN Technology and PhD in CSC. She is having 22 years of experience in teaching and research and administration of engineering education also. So her administration contributions are served as a head of Department of Information Technology, University College of Engineering since 2014 to August 2022. She worked as a special officer of New Engineering College, JNTU, Kurupam, since from May 2022, October 2022. She acted as IQAC coordinator of University College of Engineering from January 2022, September 2022. She worked as a SPOC of University College of Engineering for NPTEL online courses to till date. She has been working as a convener for Women Empowerment and Grievance Cell, JNTU University College of Engineering from September 2017 to till date. And she worked as a secretary and member for Women Empowerment and Grievance Cell from January 2014 to August 2017. So her academic contributions are she has a specialization of artificial intelligence, data mining, machine learning, deep learning, and soft computing on internet. And she authored a book titled Artificial Intelligence and Machine Learning 2022. Fortunately, she is going to deliver the same topic. We are very fortunate to having that topic. And she has been awarded as a CMI Level 5 in Management and Leadership 2021. She has been awarded as an Outstanding Woman in Engineering BIWA 2027. She has been awarded as a Women Researcher in Science and Technology 2020. She worked as a chairperson in BOS Department of Information Technology from 2017 to 2022. She worked as a member of Board of Studies for 3 years. That is from 2007 to 2010 in the Department of CSC, GIT, Geetham University. And madam's contributions are she has been awarded 4 PhDs and scholars are working for PhD at present. She published 3 patents and published more than 54 international journals, 20 international conferences, and attended international conferences also. She published 5 book chapters, and she organized 32 workshops and attended 58 workshops. She acted as a 5 session chair in international conference and also delivered 32 technical talks. And her professional contributions are she's a member of CSI and a member of Senior Fellow of IEEE, and she's a member of ISTE and a faculty sponsor of IEEE, WIE, and a faculty sponsor of ACM chapter. So among us, such a great personality, Dr. Jaya Suma madam. So welcome you, ma'am. Is over to you, ma'am.
Thank you, sir. Thank you very much for your kind introduction.
Thank you.
So, are you able to see my slides?
Yes, ma'am. You can able to see.
Okay. So today's topic is, the voice is clear?
Yes, madam.
Okay. So the topic today I want to share with you is machine learning for Internet of Things. So we know that there are a lot of emerging technologies in computers, in the field of computer science and engineering.
Ma'am, sorry for interruption. Ma'am, could you please make it full screen, ma'am, the PPT?
Okay, 1 minute. Are you able to view it? No?
Yes, ma'am.
Are you able to see it?
Yes, we can see them.
Hello, madam. Your voice is
So I muted myself.
Okay, ma'am.
Okay. Sorry for the interrupt.
share your PPT.
Yeah, I'm sharing it. Welcome to this machine learning with IoT devices or Internet of Things. So today I want to share about the how machine learning and IoT working together to generate a real-time good applications or intelligent systems. So we know in the computer science field that there are a lot of emerging technologies like artificial intelligence, machine learning, deep learning, transfer learning, big data analytics, Internet of Things, cybersecurity, cloud computing, etc. So among this, all of us are able to identify that artificial intelligence, machine learning, deep learning is the ruling the world. So you know the definition of artificial intelligence. What is artificial intelligence? We can write a program. That program can have the ability to learn by itself and reason like a human being. So when you come to the machine learning, the subset of artificial intelligence, even the deep learning is also subset of artificial intelligence. And here in the machine learning, the algorithms with the ability to learn without being explicitly programmed. When it comes to the deep learning, it is the subset of machine learning in which artificial neural networks adapt and learn from huge amount of data. Another terminology is there, that is transfer learning. So in this transfer learning, storing knowledge gained while solving one problem, and it can be applied to different problem, but which is relevant to it. So that is the transfer learning. So next, you know that in machine learning, data is the fuel. Data is the fuel. So from data to missions, how can you get the data, or how can you acquire the data, or how can you collect the data and apply to the missions or to input to the missions? So we have different types of data. That time series data is there, tabular data is there, text data is there, image data is there. So when it comes to the time series data or time series, what type of output it can be generated and where it can be used. Time series data used for forecasting purposes. For example, if you have sales, if you want to find out the stock market price or inventory optimization, these type of problems, or you want to forecast the weather also. So for these type of problems, you can use the time series or time series data. When it comes to the tabular data, all of you know that tabular data means it contains in rows and columns. The data is inserted in terms of rows and columns. So when your data is in tabular, you can detect or you can find out fraud detection, marketing campaigns, optimizations, etc. So these are applications, whatever the maybe the type of data, how we are able to store it, from where you are acquiring, but all this data is used for business application examples. So when you have a text data, now you know that latest thing that you are able to identify that text data is doing wonders. OpenAI company has introduced ChatGPT. So what it does, it is able to generate the text basing on the user information or user query. Chatbots for customer services, automatically processing customer emails. So that is the text data. Sentimental analysis, recommended systems, natural language processing. So for all this concept, you can use the text data. When it comes to the image data, so image data, you know that apart from the machine learning, we have deep learning, which is a subset of machine learning. Here, we are able to capture the image. You can give the image as an input, and where you can able to find out a business application in terms of vision systems for autonomous cars, face recognition for security systems. So government of Andhra Pradesh is also have been introduced the face recognition system for attendance. So we are all using it. So for attendance, even the school teachers also using it. So here, these type of applications, business applications, are introduced in the field of machine learning or deep learning or artificial intelligence. So previously, when we have the time series data or tabular data, we can use a traditional computational statistics. There is no need to go for a machine learning, or we can use some machine learning concepts or machine learning algorithms or techniques in order to solve this type of problems, business problems. So when it comes to the text data or image data, we can solve with the help of machine learning, we can solve a natural language processing. Or we can, when it comes to the image data, we can go to computer vision. So here, when you are taking input as a time series data, tabular data with the limited data, or not going to big data, you can use a traditional machine learning techniques. When you are going for natural language processing, computer vision, you need to go for the deep learning. So what is the difference between the machine learning and deep learning? You may have a query. That means a traditional machine learning, you can compute or you can use the hardware, a CPU. When it comes to the deep learning, if you want to execute the applications of business or real-time applications with huge amount of data, with huge queries and images, you need to go for the deep learning concepts with the hardware or the system specifications as GPUs or TPUs. So that is the difference between that. When the data is changing, when the volume of data is changing, when the type of data is changing, when the acquiring data is changing. So if you have a traditional or historical data, you can directly go for the machine learning. When you want to apply a real-time applications, you want to take data dynamically, or you want to sense the data, you want to pick up the pixels, or you want to pick up the signals, then you need to go for real-time IoT or Internet of Things. So Internet of Things contains sensors or embedded devices where you can acquire the signals or data points or data. So that is the difference between when you are applicably or when you are applying a machine learning technique, or if you have a benchmark datasets or you have a historical datasets, then directly you can take this data and implement to the machine learning algorithms. If you want to do a real-time application, if you want to sense the data, you want to take the real value at that time, at that moment, you need to go for the sensors. So sensors are nothing but you are accessing data through Internet of Things. That means you are connected with network, you are connected with the sensors, you are connected with the devices, and you are sensing the data or acquiring the data. That is the main issue of going towards that. Why machine learning should be collaborate or embedded with IoT is that is the main reason. Now, here in this slide, we will be able to view the difference between machine learning and deep learning. So here we know in terms of performance, the performance of deep learning increases when the data increases. The performance of machine learning does not improve with the amount of increasing the data beyond one single point. Beyond that point.
Ma'am, sorry to interrupt you, ma'am.
Yeah.
Ma'am, your slides are not moving, ma'am. Wasn't
Not moving? Now?
Not moving.
Now?
Not moving.
No?
No, ma'am, not yet.
Okay. In my system, they are moving. Okay. Give me
Now
a
it is okay, ma'am.
Now we can.
It is okay, ma'am.
Now it's okay, ma'am.
Okay.
Okay.
Now?
Yes, ma'am.
Yes, ma'am.
So, but it is not in slideshow. Yeah.
No, ma'am. It is visible clearly.
Now?
Fine, ma'am.
Now?
Fine.
Now? Okay.
Now it's okay, ma'am.
Okay. So here this is machine learning and deep learning. The difference between machine learning and deep learning. The hardware dependency. When it compare with the machine learning and deep learning, the hardware dependency is very less in machine learning. But when it comes to the deep learning, the hardware dependency is more. That means it requires GPUs to function that application more efficiently and more effectively. Here, when we are able to acquire the accuracy or the importance of getting the correct output, the speed also come into the picture. So here, in order to perform the applications in much faster, or why we are going all this machine learning or deep learning or artificial intelligence, we want to minimize the intervention of humans, and we want to make the task much more faster than when it is done manually with the humans. So that's why we are moving towards these technologies. So when we are moving these technologies, it is more responsible, or the role of this technology is to maintain that speed, accuracy, and efficiency. So in order to capture all these things or balance all these things, we need to move for the hardware systems with GPUs in terms of deep learning algorithms. When it comes to the machine learning, it is most applied features are needed to identified by the experts and then hand-coded as per the domain and data type. So we should able to get a relevant features when we are applying a machine learning technique. So we cannot say that these are the features that are available. With these features, we can compute and we can get the output. But we need to do some computation. We need to go for some optimization technique in order to apply a relevant and important features in order to get the relevant and more appropriate output. So when deep learning algorithms try to learn high-level features from data, the deep learning reduces the task of developing new feature extractor from every problem. So that means automatically, if you are applying deep learning algorithms, we no need to worry about the features. So whatever the efforts we are putting in machine learning, in order to get the relevant features or in order to input the more effective features, here in the deep learning, there is no requirement of that type of features. Automatically, deep learning algorithms develop the features or extract the features for every problem. So here, machine learning approach involves breaking down the problem into parts, solve each part, and combine together for final. Now here in the deep learning, It solves problem end to end. Each layer you will be getting an output, but that is not visible. So here, why the term deep learning came to picture is, deep learning is adapted from neural networks. So here in neural networks, you will be having number of layers. The minimum number of layers is 3, that is input layer, one middle layer, and output layer. So here in the deep learning, the number of layers will be increased in order to get an effective output. Okay. The training time of machine learning model takes much less time. When it comes to training time for the deep learning model, it takes more time. It may go for weeks, but you can reduce the time if you use a relevant hardware part to increase the computation. Testing takes much time than the deep learning model when it comes to the machine learning, but for training, the deep learning model takes much time, but when it comes to the testing, the deep learning models will take much less time. So a machine learning algorithm gives crisp rules as how to arrive at a conclusion. And when it comes to the deep learning, in order to get that, it is tough to interpret how deep learning algorithms did what it has performed, even though you are able to get the accurate result. So what is machine learning? So now we'll go for in-depth about the machine learning. What is machine learning? Even though in 20th century, the machine learning is ruling the world, or it became very famous, but in 1959 itself, Samuel A. has been introduced this machine learning. That means he is able to give a definition and he is able to prove that it is a field of study that gives computers the ability to learn without being explicitly programmed. So in 1997, again, Tom Mitchell has given a definition that it's stating that computer program is said to learn from experiences E. What are experiences? What are examples? With respect to some class of task T, and it measures the performance P. If we are not satisfied with the performance P, it improves with the experience E. Okay, that means the algorithm try to learn from the examples and experiences or observations. Here, the machine learning algorithm helps to gather the data from various sources, transform into rich data sets, and helps to take intelligent actions based on the results provided. So you may think that what are the examples, what are the observations, what are the experiences? So examples, experience, observations are all same. That means when you are using to collect data, we need data. Data is nothing but the experience. It can be in time series way, it can be in tabular form, or it can be in a text data, or it can be in image data. So data can be in various forms. So these examples, if you're going for the time series, or if you're going for the text data, or if you're going for the tabular data, where you can obtain this one, or where you can acquire these examples, experience, observation. For example, I'll tell you a small illustration that everyone knows in our homes. That means if you have a small child, the small child able to, if you give the small child a ball, an apple, an orange, a tomato, a lemon, so at the first attempt, even though the child don't know how to talk, how to express and all these things, but then the first attempt, the child will be able to capture all these objects or things into, try to taste it, or a child will try to put it in the mouth, or try to play with them. And the next attempt, the next day when you give all these things to the child, if the child look at it, now the child will be able to differentiate. The some of the things are for playing purpose, and some of the things that can be consumed. That means that they can be taken inside, or they can eat. In the third attempt, the child is able to know that what is ball, what is apple, what is tomato, what is orange. The fourth attempt, the child will be able to, if the child want to eat something, she will pick up the apple to eat it. And if the child is want to play, it will pick the ball to play it. So here the number of experiences, what are those? These are the observations. The first day observation, second day observation, third day observation, fourth day observation. So the child is able to make up on the fourth day or fifth day that the child, when he or she is able to attempt to pick up these things, the perfection comes. There is no misclassification. What is the task of the child? Whether the child is want to play or child is want to eat it. So here, if it is want to eat, it picks up the apple. If you want to play, it picks up the ball. So these are the observations. In similar way, the machine learning also, when you give the experiences or when you give the observations, when you give the sample data, the mission itself able to understand for what purpose these are there, basing on the input features what we are presenting to the system. So that is the most important thing. You all know why machine learning became very popular. We are in the digital age. Huge amount of volumes and variety of the data is available. From social media, you are able to get it. From big companies, you are able to get it. From everyday, like WhatsApp, you're storing some data, you're forwarding some data, you're picking some data, you're generating some data. So therefore, that machine learning became very. And now you may think that machine learning was introduced in 1959 and it was again reintroduced in 1997. Why all this time? Why the machine learning is not able to use? Why the people or the scientists, the programmers, or the professionals, software professionals, or computer science field people are not able to use machine learning? Because here, when they have introduced it, but they don't have their hardware parts more efficient. Now the hardware part is more efficient. So previously we used to have the IBM, our mainframes computers, or supercomputers. Only these computers are able to handle this type of data, a huge amount of data, or volumes of the data, or variety of data. Now we are able to get this data in a small chip. In our palm, we are having a smartphone. So we are able to compute it. So for this reason, that even though they have been introduced in the later years, this much gap has been there in order to make the hardware to be compatible with the data or volumes or with the techniques that are available, like neural networks or machine learning. So we have machine learning algorithms that are designed to be efficient, accurate, and provide general learning, like dealing with large-scale problems, making accurate predictions, handling variety of different learning problems. You can do different learning problems. So this is the difference between traditional programming and machine learning. So when it comes to traditional programming, all of us knows that C programming, we have to write a program, we have to write a code. And when you want to execute it, when you want to generate an output, you need to give input or data to it. That is the traditional program. When it comes to machine learning, here you will not write the program. The machine itself generates the program. But what you are supposed to give, we have to give the input and we need to give the output. Output is in terms of class labels. The output is in terms of class labels. That is data and class labels also. So here the key elements of machine learning. You may say that we are hearing machine learning, what it requires in order to apply machine learning or in order to use machine learning. So the representation is more important. How you will be represent the knowledge. It can formed from the decision trees, set of rules, instances, graphical models, neural networks, support vector machines, model ensembling, etc. Case-based reasoning, some optimization algorithms like genetic algorithms and colony algorithms, ABC optimization algorithms. Lot of things are there. So we need to select some representation. How we can represent that knowledge. What technology or what method we can use. What algorithm can we use. We need to see that whether this algorithm can fit into the for the data or not. Next, after you have represented how you have taken that, next is evaluation process. The way to evaluate the candidate programs, it can be accuracy, posterior probability, margin, cross-validation, confusion matrix, hold-out methods. If it is cross-validation, tenfold cross-validation, etc. When it comes to that, if you are not satisfied what you have evaluated, if the percentage of it is very less, you are not satisfied with the accuracy that is obtained by the selected representation, then you will go for the optimization. Optimization means improvement. That means you will increase the samples and you will increase the algorithm also, efficiency of the algorithm by introducing some optimization techniques. So these are the three different key elements of machine learning. So steps involved in machine learning. What are the steps? First, we need to take a problem, that is problem identification. Define, understand, clearly describe the problem that is to be solved. Whether you want to find out that mushrooms are poisonous mushrooms or not poisonous mushrooms, that is the problem statement. Whether we want to find out that whether is comfortable for flight landing or not. The problem statement can be whether you are trying to find out the person is having cancer or not. So what we are supposed to have, we need to have some features for it. So where you can get this features or where you can get this data. You can get the data from benchmark data sets or historical data sets. You can use this training data set from benchmark data set or historical data set or previous data set, whatever you have there. But when you want to find out for a real-time application, dynamically, you need to acquire data. So where you can acquire data? Now here, for acquiring the data or getting the data, you can apply Internet of Things. Things means what? Things means nothing but the devices. Whether it can be mobile phone or your home equipment, anything. It can be anything. So here, after the things, you need to prepare the data for finding out the things. Here, you can see that you can use Internet of Things. So Internet of Things, if you want to use Internet of Things, you need to have some infrastructure. So what infrastructure is required? Sensors are required to sense the data. You need to have networking. You need to have analyze the data. So to analyze the data or prepare the data, you need machine learning there.
Ma'am, slides are not moving.
Now,
It is still showing machine learning, deep learning comparison only. That slide you can able to see. Now it's moving, ma'am.
now what it is? I
Machine
think,
learning with IoT.
okay. Okay. Now,
The traditional programming, machine learning.
yeah. Key elements of machine learning I have already told. Now,
Yes.
start.
Yes, ma'am. Steps involved in machine learning.
Now, what you are able to view, just
Steps involved in machine learning.
next.
Same we can. able to see the steps involved in machine learning.
Yeah. There is some problem with my mouse. If I am using mouse, I'm not able to view it.
Okay.
That is the problem. So here the steps involved in machine learning, if you have a problem, you can take a problem. So in order to acquire the data, what type of data you are using, some mode of acquiring the data, whether if you are going for the real-time application, you can sense from the IoT devices. If there is no requirement of sensing the data or getting the data dynamically, your application requires only static data, then you can apply, or you can get the historical data. So here, after getting the data, you need to prepare the data, analyze the data. So for preparing and analyzing data, you need machine learning. So when you are using IoT devices or Internet of Things, if you want to, whatever the result you have obtained or whatever the output you have obtained, so that if you want to post it or upload it in some server or a cloud, there you can be using a dashboard to apply it. Okay, so there it is required to have a internet also. Internet connectivity, getting communication. You need to have the communication between these devices. So if you have 5 devices connected together to do some automation, then all these devices should be connected together with some network, and you can able to acquire the data and compute it, analyze it using some data analytics. So I think next another emerging technology come to picture. If you are having huge amount of data, very huge amount of data to be handled, then you can use some big data technologies over here in order to compute it and analyze it. Or if you want to generate some reports, you need to go for data analytics. So here, when you are analyzing the data, here understand the information available that will be used to develop the model, determine the structure or representation of learned function. That means here, if you are determining structure or representation of the learned function, that means here the representation. So what type of representation can be used here means whether you're going for the decision trees, whether you're going for the supportive estimations, or whether you're going for the genetic algorithms or naive-based classification or neural networks. Here, when you are analyzing the data, you have to see that whether these representation can fit to your problem statement or not. That is one thing. And next thing is whether your data is a huge or limited data. That is another thing. Whether you're going for the static data or a dynamic data. If you're going for the dynamic data, you need to use internet devices, or sorry, IoT devices or Internet of Things. And this representation, after representation, you are completely evaluate that algorithm. You need to evaluate that algorithm. Evaluate the accuracy of the learn function. So for evaluation, you have many metrics. Performance metrics are there. For evaluation metrics are there. Lot of things are there. Like you can go for precision. You can go for recall. It depends upon the representation you have selected of the learn function or learning algorithm. So you will be able to extract a wealth of information. Here, 2 concepts comes to the picture. One is where you want to deploy it. If you want to deploy it, on a server or a cloud. So what technologies are required to deploy it? Next is, if you want to do some decision, you are able to generate an intelligent system, then you have go for analytics. So what type of analytics? We have 4 different types of analytics. So what type of analytics can be applicable here? Next is, when you have been able to generate the result or wealthy information, you need to visualize it. You need to visualize it. That means you need to represent in a pictorial representation. That is the things. So the goal of all these things is to seek a best working model. For what purpose we are seeking this working model? In order to make an intelligent system, or we know to forecast the things depending upon the problem. So what is the next slide? You are able to view it. Can anyone?
Machine learning with IoT, ma'am.
Yeah. So, okay, thank you. So here, machine learning with IoT. This topic explores how to use data analysis techniques to optimize the performance and functionality of the connected devices. You cannot say that I'm using a single device. So this is my device. Now we are connected. So many things. All of you are connected with different laptops, with Wi-Fi, with a platform. What platform? Google Meet is the platform we have connected. So here we need to do some data analysis or data analytics to optimize the performance and functionality of connected devices. It can be used to project future trends, detect anomalies, augment intelligence by injecting image, video, audio, anything. We can use multimedia. We can use multimedia in order to make much more, whatever the model we have made. If you want to make the model much more smarter or much more intelligent, or if whatever the model you have generated is a system, so that system should be much smarter, much intelligent. And not only making it intelligent, it helps to clarify the hidden patterns in IoT data by analyzing massive volumes of data using some sophisticated algorithms, advanced algorithms, fine-tuned algorithms. So people who are doing the research in machine learning or deep learning able to understand that a single algorithm or a single traditional algorithm is not enough to proceed further to get an intelligent system or a sophisticated smart system. You need to embed with, or you need to connect with number of devices and number of algorithms in order to make it optimize the performance. I'll give you 3 examples why accuracy, when you have developed a model, why accuracy is important in these models. Simply when you are making your students to do some programs in your laboratory, the student much worried about that whether he is able to generate an output or not. Any program, either it can be a C language program or a Python program or a machine learning program or anything, whatever it may be. He is much worried about that whether he is able to generate the output or not. So he will not go for a number of combinations or permutations or number of results and number of tasks. But when it comes to a real-time problem, or when you are trying to solve a smart problem in smart way, we need to see number of combinations, not only developing, not only implementing the algorithm, not only getting a good result. We need to go for the good accuracy in that particular view. The first example is to classify whether the mushrooms are poisonous or non-poisonous mushrooms. mushrooms are poisonous or non-poisonous mushrooms. So when you know that 5-star hotel will be having a mushroom as a dish. So when a vendor gets the mushrooms, here the task, what is the machine learning task? To classify that whether it is a poisonous mushroom or non-poisonous mushroom. So your model is saying, you have built a model and the model is able to say that a poisonous mushroom as non-poisonous mushroom. This is called misclassification. Poisonous mushroom is classified as non-poisonous. What happens here? Since that algorithm or the model is able to say that it's non-poisonous, the hotel manager will be consuming or will be taking it and preparing the dish. And what is the risk? The people who consume it will be falling to sick or the life risk is there. And the next vice versa, if you think about the vice versa, that is, if a non-poisonous mushroom is classified as a poisonous mushroom, then the manager will not consume these mushrooms and he will be simply discarding these mushrooms. So see the risk in both the things. If a poisonous mushroom is classified as a non-poisonous mushroom, there is a life risk. If a mushroom, even though it is poisonous and non-poisonous and classified as a poisonous, there is only a whatever the amount you have purchased regarding that mushrooms only wasted. That is the thing. Next application, I'm going to say that here you have built a model to state that whether that flight can land or not. If a pilot get a signal that even though the situation is at the aerodrome is favorable for flight landing, and they think that your model says that it is not favorable for landing. In this case, what that pilot does, he tries to roam in the air until he gets the signal or whether is able to have a good situation or comfortable for landing. Okay. In this case, see this, if there is a misclassification, there is a wastage of fuel. And even though there is not having, that flight is not having enough fuel, and if it is trying to roam in the air, that is also dangerous. If the aerodrome is not favorable for flight landing, and if the flight makes landing, it is also dangerous. In both the cases of misclassification, there is a 50% of dangers. Okay, that is the thing. Next example is, we take for the, you have developed a system stating that whether the patient is suffering with cancer or not. If there is a misclassification, that even though the patient is not having cancerous, but the system is able to say that it is having cancerous, then the doctor will be giving prescription and he will be put into the medication. That is also a dangerous thing. Even though the patient is having cancer and it is able to say that he is not having cancer, both the cases, both the cases of misclassification, the patient or the input data is in risk. The person will be in risk. So here we are able to know that what problem you are selecting. So what is the accuracy, acceptable accuracy, we need to see that, and how to proceed it. That is the things that we need to know before you select a machine learning problem in order to select with the representations, different representation. So coming to the machine learning application for IoT, smart home automation. Smart home automation. All of us know that smart home automation. So if you have, you can have a voice input. Basing on the voice, if the 4 people are living in the home, basing on the voice, they are able to open the refrigerator or open the door, or basing on their biometrics, they can open that. These are all smart home automations. Predictive maintenance, health monitoring, facial recognition, all this comes with machine learning with IoT applications. Okay, some other applications, that is smart home automation is used to connect the devices and sensor to control and monitor various aspects of home like lighting, temperature, security, entertainment. You can, basing on the number of objects or the things that are there in your refrigerator, the temperature is set to that. So what are the benefits that you can get from this smart home automation? You can learn from the user behavior and preferences, automate the taste based on the patterns and the prediction. For example, if you're using your television, basing on your age, it is able to recommend that what type of movies you, or what type of things you can go for it. Whether you can go for a cricket match, or we can go for the movie, or you can go for the news. Depending upon the taste, it will be done. Okay. So in one of the application of smart home automation using machine learning is adjusting the thermostat based on the occupants and the weather. And you can play music or videos basing on your mood. Immediately you enter into the home, the device, that IoT devices or the connected devices sensors will be able to capture your mood, and basing on the mood, they will play the music. Locking and unlocking the doors based on the facial recognition or biometrics. Alerting the homeowner if there is an emergency or unauthenticated person without a permission. If he enters, you will be getting a notification or alert message. So this is an example. That is how you can set up a home automation system using the following systems. You can use a smart assistant to act as a central hub for controlling the smart devices. So most popular options are Amazon Alexa, Siri, Google Assistant, all these things. You can use a smart speaker also to display the support of chosen assistant. Okay, and you can pick smart devices and your wireless network. Network is also is important here. Without any network, you cannot operate. Okay, this is and you can use some app or a dashboard where you can able to display the things what is happening also. That is the another important thing that we can connect with this. Next is Internet things. What is Internet things? We have learned what is machine learning, and we will learn what is meant by Internet of Things. Internet means network with connection with other people. Things. What are the things that are connected? Internet things refers to the networks of interconnected physical devices, objects, and systems that are embedded with sensors, software, connectivity capability, enable them to collect and exchange data over the internet. So if there is no exchange of data, we don't know what is going on. So that connectivity is required, exchange of the data is required, collecting data is also required. To collect the data, we need some physical devices, or with sensors we need to sense it, and it requires some software also. Depending upon the sensors and depending upon IoT devices, the compatibility of the software is also decided. The compatibility of software is also decided. IoT allows things to be sensed, controlled remotely, resulting in improved efficiency, accuracy, economic benefit, in addition to reduce human intervention. So here, even the public government is also working very hard to optimize the devices, like electrical board. They are able to give the smart electricity. That means grid. They are able to see that depending upon the weather, outside weather, whether we can switch on the AC or not. That is the smart thing. Things include everything from temperature sensors, cameras, smartphones, buses, trains, almost everything else that we can think of. Okay. So these devices, so if you are not connected with internet, these devices are simply devices, simply physical devices or embedded devices, we can say that. If they are connected with the internet, then you can say if there is a connectivity is established, then we can say there are smart devices. So these devices can range from everyday object like household things and wearables to industry machinery, vehicles, and infrastructure. Outside infrastructure also. Here, for example, an air conditioned AC sensor can gather the data regarding the outside temperature and accordingly adjust its temperature to increase or decrease it with respect to the outside climate or outside weather. Similarly, refrigerators also. So they interact with the network and they adjust their readings or the data. Therefore, dynamically, therefore they are called as smart devices. So what are the advantages of IoT? Why we need to go for IoT? So IoT created opportunities to directly connect and create a link between the physical world to the computer-based system. You're working with the computer system. If we are not having internet, we cannot connect it. You cannot hear my voice. And you can sense it by using some sensors also, devices. Okay. So here, when you are including technologies to the smartphones or to the devices like smart meters, smart grids, smart homes, intelligent transportation, smart cities, you are making much more automation and much more advanced application, enabling advanced application in different fields. That improves the accuracy, efficiency, and minimize the manual intervention. It minimizes the manual intervention. That is the very important. Here, extracting. So you're saying that we are using internet and it is giving a advanced application. It is able to, you are able to get the advanced application by using IoT. Then here, how you are able to get this data and how you can do this, all this computation. That is our question. That's why we need to integrate together with AI and IoT to get much intelligent systems. Why machine learning should work with IoT, or why machine learning should combine with IoT to generate intelligent systems. Here, when you are extracting meaningful insights from data, you have data. So where you can get the data, you can get the data. If you are an educational institution, you can get the data, how many students are admitted. If there is outgoing students, how many students got placements. Okay, how many are admitted, how many are placed. So if you are able to get the data from that, if you want a satellite image, how the clouds are there, what is the temperature, whether it will be a rainfall tomorrow or not, whether I can go to school or not. So we need to have some sensors in order to capture this information. Or you can take from image, or you can take from microscope, or you can take from spectrographic. You can use spectrographic, or you can use internet devices, IoT devices to get it, the information. And you need to put it into the input-output system, like you need to store in some place. So that place storage device, it can be a database or a network cluster or hard drives. And you have to have a computing platform for it, like a GPU. So in order to retrieve a hidden patterns from it or extract that knowledge from it, or in order to do some decision making, or in order to do some analytics with it, you need to have a computing platforms. So what are the computing platforms you are there? Whether you are having a GPU, CPU, TPU, cloud or distributed, what are the things that are required to maintain these things, this hardware? Where you can obtain those things? How to connect with those things? How to maintain those things? How to interact with those things? Okay, you are able to capture the data using sensor. How we need to connect to our input-output systems, how we need to compute it, what are the requirements to compute it, how to develop scalable algorithms from it, whether it is indexing, streaming or sampling, and what type of models we can generate from it, whether we can predictive models, whether it goes for classification. That means predictive model is using whether it is a supervised learning, unsupervised learning, reinforcement learning, or semi-supervised learning, or you are just displaying in a dashboard for further reference or to make public view it. Okay, that we have to know it. And you need to obtain the output, domain context, what type of output that is generated. So here we have talked about these things, but I didn't talk about different types of machine learning algorithms. I didn't talk about the machine learning algorithms. Now we'll go for the machine learning data. So when you are preparing the data, you have captured the data. When you want to put it in the database or a data warehouse or a network cluster or a hard drive, how you need to prepare the data? What type of analysis is required? So if your task is to predictive, you need to know the objective or the purpose of data analysis. Explorative, descriptive, or predictive. If it is a descriptive, what type of computation you have to prefer? What type of algorithms you have to pick up? Whether you should go for the traditional statistics, or you need to go for traditional machine learning, or you need to go for advanced machine learning, or you need to go for deep learning. That you need to think. Where does the data come from? The source of data. Whether you are picking from IoT devices or a sensor, or you are getting from internet, or you have a benchmark data set, or you have a data from your hard drive, or you are getting data from your social media. From where you are picking up the data, whether the data is compatible for your problem or not, that you have to do. How was the data acquired? What is the method you are collecting data? You know that you have sensor, but what software you are using to collect the data from that sensor or embedded device or that IoT device? How informative is the data? The quality of the data. Check the quality of the data, outliers, missing data, anomalies. What assumptions are being made on data generated, whether it is a linear or non-linear. Okay, all these things should be, you have to know all these things before you go for that data preparation. So machine learning process flow is data gathering. You have to pick up the data. Data should be pre-processed. Choose the model. Here, choosing the model, what type of model you have, whether you're going for neural networks, you're going for support vector machines, you're going from decision trees, you're going from name-based classification, whatever. You have to train the model. For training the model, you should have some training samples also. Whether it is a time series data, whether it is a tabular data, whether it is a image data or a text data. Test the model, tune the model. Tune the model is nothing but the optimization. You have to go for hyper parameter tuning optimization also. So these are some of the applications. We don't want to go much into these details because all of you know what are the applications of machine learning. So here the machine learning algorithms are classified here. So here many textbooks says that there are only 3 machine learning algorithms, but according to my view, I can say that machine learning algorithms are classified into four. That is semi-supervised. Many textbooks says that it is having two different types of machine learning, that is supervised and unsupervised. Later, they have introduced reinforcement machine learning algorithm. And since my research into it, I'm able to say that it is semi-supervised machine learning algorithms. So coming to the supervised machine learning algorithms, what are supervised machine learning algorithms? You will be having some trained examples. Algorithms are trained using labeled examples. Labeled examples. Examples, you know. Labeled exams. Some data you don't have the labeled examples. Then you can say that it is unsupervised learning. So labeled example, labels acts as a supervisor, such as input where desired output is known. Okay, unsupervised, you have a data, but there is no historical labels. The task is to, you have to organize the data basing on the similarities. Basing on the similarities. Here, organize the data into groups of clusters to describe its structure and make complex data look simple and organized for analysis. How you will group into clusters? You will be grouping into clusters basing on their similarity, basing on the distance between those objects. What is semi-supervised learning? Some applications, some real-time applications, you will be using both labeled examples as well as unlabeled examples. This type of learning can be used with methods such as classification, regression, and prediction also. That means there are applications where you can use both classification and regression and prediction. Identifying a person's face on webcam. Next is reinforcement learning. Choose an action based on each data point. Later, learn how good the decision is. Over time, the algorithm changes the strategies to learn better and achieve the better result. Here we have two different modes of reinforcement learning. One is exploration and exploitation. When it's exploration, you will find more information about the surroundings. Exploitation is information to be maximized. For example, some friends will be visiting your home. So when they visit your home, if you are taking your friend to the favorite restaurant, it is exploitation. When you are trying for a new restaurant, someone has told you that it is a new restaurant and it will be good, but you didn't try it. In previously, already many attempts you have done it and you have come to a conclusion that it is your favorite restaurant. Exploration is you are trying to new restaurant. Someone told, but you didn't. That is the thing. So this is the reinforcement learning. So here in the machine learning, we have here in this picture, I have categorized supervised learning, unsupervised learning, reinforcement learning. So data with labels, we can say it's a supervised learning in simple words. So here we have two different types. One is classification, another one is regression. So how can you say that it's a classification problem? How can you say that it's a regression problem? Here, according to this picture, you are able to say that classification can be done using these algorithms, and regression can be done with this using. When your data is discrete, when your class label is categorical, then you can solve that problem with classification. If your data is continuous, the label is continuous, and the label is numeric, class label is numeric, then you can go for the regression. So how to identify? If you are able to identify that it is a supervised learning, that means the data set is having labels. If the data set is having labels, then you can easily say that it is supervised learning. But in supervised learning, you have two different operations. One is classification and other one is regression. How can you identify this is a classification problem, this is a regression problem? If the class label is discrete, categorical, then you can say it's a classification problem. That means whether the student has been passed or not. It's a classification problem. How much the student has been got in his exams, whether it is a 70% or 80%, then it is a regression problem. Okay, you are able to distinguish between these two. So in regression, the class label is continuous numeric value. Here, logistic regression, even though it says that logistic regression, but it's a classification algorithm, name-based classifier, K-NERIST classifier, neural network, support vector missions. What are the examples you can say? Whether the email is spam or not. Speech recognition. These are all comes under the classification. Regression, linear regression, rigid regression, ordinary least square regression, stepwise regression, polynomial regression. All this comes under the regression. What are the example of it? Stock market prediction, rainfall prediction. What will be tomorrow? Weather. Whether it is sunny or rainy. That is a classification problem. What is the temperature tomorrow's weather? Whether it is a 26 degrees or 32 degrees or 40 degrees. That is a regression problem. Okay. Well, coming to the unsupervised learning. So if you are having data without label, then it is called as clustering. Clustering, that is unsupervised learning. In clustering, in unsupervised learning, you can do clustering, you can do association analysis, you can do dimensionality reduction. So in clustering, you can apply K-means. What is clustering? Clustering is nothing but you have a data, you don't have labels, but you need to group the data. How many groups? It depends upon the similarity. If there are dissimilar, you can group in two. That is pass or fail. You can group it. How can you say the pass or fail? What is the pass mark? Less than 40%, greater than 40%. Here the threshold is less than 40%, greater than. Less than 40% is fail and greater than 40% is pass. So if you want to make the class into three clusters. Now I want to make the class as two clusters. I can make the class as girls and boys, depending upon gender. I can make a class basing on their marks, whether they are pass or fail. I can make class into two groups, whether that they got the placements or not. I can make the class whether they have backlogs or pass, whether students are bad or good. This is very tough job. You have to embed another machine learning algorithm or optimization algorithm to state whether the student is good or bad, because there is no benchmark for good or bad. So how can you say the student is good? Because he is good looking, or he is attending the classes, or he got good marks. So a lot of parameters should be included in order to state that student is good or not. But what is the parameters to state whether the student have been passed or failed? If he have got less than 40%, he is failed. If he got more than 40%, he is passed. So there is a threshold, there is a similarity. How can you measure the similarity? We have a lot of measures, models. We have to find out the distance between two objects. So to measure the distance, you have a distance measures. That is, in order to find out the similarity, you have to apply some distance measures. What are the distance measures? Euclidean distance measure is one thing. There are a lot of distance. So what algorithms contribute to say that this is clustering algorithm? We have to find out these groups. clusters, we have k-means, k-median, hierarchical clustering, partitioning clustering, expectation maximization, DB scan, denogram, etc. So how identify the fake news? Document analysis, whether it is a fake or not. Coming to the association. Association means association analysis. If market basket analysis, that means market basket analysis means nothing but when you go for the electronics shop or a supermarket. If you are purchasing bread, there is a chance of purchasing bread you cannot eat alone. You have to put some butter or cheese, or you need to have a milk, or you need to have a jam, etc. So here, when you are picking some item, what are the other items can be picked together or purchased together? If you are purchasing a computer system, there is a chance of purchasing a webcam. There is a chance of purchasing a wireless mouse. There is a chance of purchasing a printer. There is a chance of purchasing a good keyboard, mouse pad, etc. So for this type of association analysis, you have an algorithm called as a priori algorithm, FP growth, all this algorithm. Next is dimensionality reduction. What is meant by dimensionality reduction? Reducing the size, or here we can reduce the size based on the records, based on the features. So we have some techniques like feature extraction, principal component analysis, PCA, ICA, feature selection. You have feature selection. What are relevant features? Wrapper, filter, embedded methods. So if you are working with a deep learning image, then you can go for autoencoders for feature extraction or dimensionality reduction. For this, examples are analysis of written text and DNA microarray data. So this is a brief thing about unsupervised learning. Coming to reinforcement learning, we have two types, model-free and model-based. Model-free is trial and error method. You don't have a model, you don't learn a model, or you won't build a model. Q-learning, hybrid, policy optimization comes in model-free, and model-based is learn the model, given the model. Example is motion planning, navigation, multi-agent system, etc. So these are some of the things, different types of machine learning that we have. So when you come to the supervised learning, here you have input data, and we have labels. What are the labels? These are apples. You have given a label, these are apples. And that when you give an apple to the model, says that it is an apple prediction. When you give an input model with apples and oranges, here that is unsupervised learning. How it learns is the oranges are in one group and apples are one group. So that is how what you called as it does, or it clusters, or it groups into different objects. Let's see this in supervised learning. So what are features? We said that if we need to have some features. We can reduce some features. Here, how can you say that it's an apple, or how can you say that it's a papaya? How can you say that it's in a guava, pomegranate, or so here, depending upon the feature, size, color, shape. Here we have given 3 features and 1 label. This is the class label. Small and red round shaped is, we can call it apple. Big and yellow, oval shaped papaya. Small and green, you can say guava. Small and pink or red, round, like a crown, you can say the pomegranate. So these are supposed to be given to the machine to state that method. So this is the architecture of the supervised learning. You will be doing training samples, like in form of text or documents or images or sounds. You will be generating a feature vector, and that is given, and labels also be given to the machine learning algorithm. And machine learning algorithm will be generating a model that is called as a predictive model. And when you give a new sample, unknown sample, here our task is to find out the label. So if the expected label is same as the given label, then we can say it's a good 100% accuracy. If there is expected label is not equal to given label, then we can say that it's a misclassification. Then you can say that's a misclassification. This is unsupervised. Here you will not have labels. See the picture, you will not have labels. So the same inputs are given, feature vectors are given to the machine learning algorithm. When you want to find out, you will be finding out with better representation or cluster ID and likelihood. What is the maximum likelihood of it? So these are the learning techniques: supervised, categorical techniques, linear classifiers, parametric means you have to give probabilistic functions. Here we have different types of probabilistic functions, that naive-Bayes, Gaussian, hidden Markov models, probabilistic graphical models. If it is linear classifiers, numerical functions. If it is non-parametric, instant-based functions like K-nearest neighbors, canal regression, canal density estimation, local regression. Non-metric is symbolic functions like classification regression trees. In decision trees, we have different types also. And here C4.5 is one thing, CART is one thing, and ID3 is another thing. Depending upon the samples, class labels, type of class labels, you can say whether it is a CART or C4.5. You can work with C4.5 or ID3. Aggregation, how we can do is bagging, AdaBoost, random forest. So supervised learning, we have already seen that we can do classification and regression, but probability estimation can also do with the supervised learning. And the output function is probability. If you're giving the probability output function, and when you are dealing with probability, you can go for the fuzzy also. Probability function. If there is, if you are unable to classify that the traffic jam is high or low. Today the traffic jam will be, how can you say that traffic jam is high today? Or today is you don't have traffic jam. It depends upon the yesterday traffic jam. So whatever the traffic jam you are having in Visakhapatnam, it doesn't mean that the same traffic jam, if you are staying, your vehicles are at halt position, not in moving position, more than 5 minutes in Visakhapatnam, then you can say that's traffic jam. If your vehicles are not moving more than 15 minutes, then in Hyderabad, you can say it's a traffic jam. When you go for Delhi, if it is more than half an hour, then you can say it's a traffic jam. But it is usually less than 30 minutes in Delhi is usual. You cannot call it as a traffic jam. So that type of situations we have to consider, and we can say it's a fuzzy. We can solve this type of problems using fuzzy logic. Okay, that is. So regression, we have a number of techniques like linear regression, multiple regression. Classification, you can have logistic regression, decision tree, support vector visions. And how can you say that a given problem can be solved with supervised learning, unsupervised learning, or semi-supervised learning, or reinforcement learning? So depending upon the problem statement, what is your expectation? What is your output? If you have how much and how many, then you can say that regression. How many marks you have obtained, then you can say that this is a regression problem. What is the cost of the house? What is the rainfall? Then it is a regression problem. If the traffic is high or low, the temperature is high or low, whether it is a true or false, whether the student has passed or not, then it is a classification problem. Is this A or B? How this is organized? Then it is a clustering, unsupervised learning. Is it wired? Anomaly detection algorithm. That is semi-supervised learning. What should I do next? If there is a traffic jam or if there is an accident in this path, what path I have to pick in order to I have to move to the airport? Because your flight is scheduled at a fixed time. If you are not there in that stipulated time period, you will miss that flight. So if whatever the path you have chosen, if there is an accident in that path, what is the alternative path you have to do next? That is reinforcement learning. So these are the different types of problems that you can apply in the machine learning. So when will the IoT come to the picture is when you want to take a dynamic, you can sense, pick up the information data dynamically, real time, then IoT devices come to the picture. And if you want to make the intelligent system much faster or much smarter with all other parameters, and if you want to go for the analytics, then you need to embed IoT with machine learning and find out a solution to the problem and make the system more intelligent and more smarter. Then you can embed those things. Okay. So what is the temperature today? What is the age of your kid? What is the price of the land? Is regression problem. Okay, I think, can I stop here, sir? It's already 9:30. Can anyone of you help me?
Yeah, ma'am.
Can I stop? I think I have given some overview regarding how we can collaborate with machine learning and IoT. Any questions up to this?
Yeah, participants, can anyone ask any questions? Oh, madam.
If no questions, fine.
Yeah, ma'am. Shall we wind up the session, ma'am?
Yeah.
Okay. Just a moment, ma'am. Well, ma'am, thank you for coming and delivering the expert talk, ma'am. We'd like to propose a formal vote of thanks to this session. We would like to express our sincere gratitude for the insightful and engaging talk you delivered on machine learning for Internet of Things, ma'am, at this third International Conference on Machine Learning and Big Data Analytics, ICMLBDA 2023. So your expertise and passion for the subject matter were truly evident throughout the session. Your presentations were not only informative, but also inspiring. So the way you explained complex concepts in a clear and concise manner helped us grasp the intricacies of machine learning in the context of the Internet of Things. So your ability to connect theory with the practical applications left a lasting impact on us and further fueled our interest in this field. So we particularly appreciate how you presented real-world examples and the case studies demonstrating the transforming the power of machine learning in various IoT applications. And your in-depth knowledge and the way you conveyed with enthusiasm made the topic come alive and spark new ideas in my mind. So thank you once again for sharing your knowledge and expertise on this particular topic. So your talk has undoubtedly broadened our understanding and deepened our interest in this rapidly evolving field. So we are grateful for the opportunity to learn from you, and we look forward to exploring further advancements in the intersection of machine learning and Internet of Things. So wishing you continuous success in your endeavors, and we hope our paths cross again in the future. We look forward to hear the same kind of sessions for the forthcoming talks, ma'am. Thank you once again, ma'am. Thank you.
Thank you, sir, for your encouraging words and kind support. Thank you, one and all, for bearing or sparing your valuable time regarding this session. Thank you.
Thank you, ma'am. Thank you once again. The participants will share the feedback link and you can catch up the next session by 12:30. Please monitor the WhatsApp group. Thank you. Thank you, ma'am.